To expand a logarithm, we're going from a complex expression to a simple one. For example, if we're adding two logarithms, then basically we are going to write it as a single logarithm where the arguments are being multiplied. Or if we want to condense a difference, in other words, we're subtracting logarithms, then we're going to condense it as a single logarithm where the arguments are being divided. Suppose we had to condense the following logarithm. Notice that we're adding here. So because we're adding, we're going to take the two arguments and multiply them. So we're going to use our product rule for logarithms, and we're going to say that this is equivalent to log base 8 of 5 times 12. In other words, log base 8 of 60. In this particular expression, we're going to need to use more than one property. We know that because we're adding, but we're also multiplying a log by a particular value. Why don't we take care of the 1/9 first? And the reason why we're taking care of the 1/9 first is that we want to make it basically log of something plus log of something so that we can apply our product rule. So our power rule says that this 1/9 basically was a power applied to our argument. So we can rewrite the expression as log base 5 of 6 plus log base 5 of x to the 1/9. Now what we see is that we're adding, and our product rule says that as long as we're adding logs, we can go ahead and multiply the arguments. So this is the same as saying log base 5. Now let's multiply the arguments. So we're going to multiply our 6 and we're going to multiply our x to the 1/9. So it's going to become 6 times x to the 1/9. So this is our condensed logarithm. Pause the video and see if you can try this one yourself. Okay, so we notice first that this 1/2 needs to become a power of the 9, and this is basically because of our power rule for logarithms. So if we rewrote everything, we'd still have the log base 3 of 21 minus, but this time the second part we'd write that as log base 3 of 9 to the 1/2. Remember that 9 to the 1/2, half powers are square roots. So 9 to the 1/2 is basically the square root of 9. And the square root of 9 is equal to 3. So our 9 to the 1/2 is basically 3. So if we rewrote everything, then we're saying log base 3 of 21 minus log base 3 of 3. Notice that we're subtracting here. Our quotient rule says that this is basically the same as taking the arguments and dividing them. So if we rewrote everything, then this is basically equivalent to log base 3. We'll take our two arguments, 21 and 3, and divide them. So it's equivalent to saying log base 3 of 7. So this is our condensed logarithm. For this particular question, it might look like it's different, but it really isn't. So how do we handle this? Well, first of all, when we are dealing with this ln, it stands for the natural log, or natural logarithm. And what a natural logarithm is, so far we've had log base 2 as an example, or log base 3, or log base 5. For a natural log, it's equivalent to saying log base e. Remember that e is approximately, it's a number like pi that goes on forever, whose decimal value goes on forever and does not repeat. So e is about 2.7182, etc. So the rules that we've been applying are going to apply equally to the natural log. So here, notice that we're adding. So when we add, remember our product rule says that adding a log is the same as taking the arguments and multiplying them. So what exactly would happen if we did the cube root of 5 times the cube root of 25? Well, we can multiply underneath a root, and 5 times 25 is 125. So this is equivalent to saying the cube root of 125. The cube root of 125 is 5 because 5 times 5 times 5 equals 125. So let's go ahead and continue reasoning this out. So if we follow through, we're going to say, first of all, again, because it's addition, we're going to multiply our arguments. So what we have here is equivalent to the natural log of the cube root of 5 times the cube root of 25. When we multiply our argument, this part right here, it's equivalent to saying the natural log of the cube root of 125. The cube root of 125 is 5, and so our final answer is the natural log of 5. So this is our final answer. Pause this and try this one yourself. So the first thing that we want to notice here is that we're applying the quotient rule because we're subtracting two logs. So this is equivalent to saying 5 times the log of the quotient of h and j. So that's h over j plus 3 times log of k. The next thing we'll notice is that this 5, because of the power rule for logarithms, this 5 can come to the argument as a power, and this 3 can come to the argument also as a power. So if we rewrote everything, we were saying log of h over j to the 5th plus log of k to the 3rd. And because we're adding here, it means that we're going to end up using our power rule our product rule for logarithms. So we're going to say the log of h over j to the 5th is now going to be multiplied with k to the 3rd. And because we can't really do anything with this, we're just going to leave it exactly as it is. So this is our final answer. Actually, correction. Let's go ahead and do some more work with this. Remember, this 5th power can be applied to both the numerator and denominator. So we're going to say that basically what we have here is log of h to the 5th over k to the 5th, log of h to the 5th over j to the 5th, and that's still being multiplied by k to the 3rd. So if we want to make this look a little bit better, this k to the 3rd is really k to the 3rd over 1. So if we multiplied everything, it's like saying log of h to the 5th, k to the 3rd over just j to the 5th after we do our multiplication. So this is our final condensed logarithm.